Well, here we go with lesson 1.3. We're solving equations with variables on both sides. If you've caught along, we're going to be solving solving equations in this entire chapter. Chapter 1 is all about solving equations. This is kind of the foundation of what we're able to do the rest of the year, is working with these equations and how to solve them. And on these ones, uniquely, the variable is going to be on both sides. So far, we've had the variable in one place, and we've kind of moved all the numbers away from it so that we could isolate the variable. Now the question is, well, what if it's on both sides? And so to do that, we're going to start with some problems like this. It says the value of the figure's surface area is equal to the figure's volume. Okay, and so what that means is this. We know, kind of zoom out here for a minute, we know on these problems that the volume of this object is equal to its surface area, which kind of means you need to know this formula. Now, I know not everybody does, okay? So the surface area of a prism is perimeter times the height plus 2 times the area of the base. The perimeter is, like, take this, we'll call this the base, okay? Really quick. Let me grab my example here for us because I think it helps. No matter what way I hold this, if I were to take this and hold it like this, I think you would all understand, looking at this water bottle, that the base is here. Okay? So even if it's standing like this or it falls over, you guys would say, oh yeah, that fell over. And the base is here, and so you need to stand it up. So the base on a lot of the shapes you're going to see are the front of the object, not necessarily the bottom, okay? And it depends on the shape and it depends on the picture. But in this case, we're going to call this the base. And the base is, I don't know if it's a square or a rectangle. It looks like a rectangle. So the perimeter of that base is 5 plus 5, the top and the bottom, plus x. We're going to multiply all of that times the height, which is 10. And then plus 2 times the area of the base, which is 5 times x. Base times height. Okay. And what they're saying here, we won't even bother with number 2, just to deal with this first one. Okay. Right? I don't want you guys to get lost in the surface area and volume parts, though this is a portion of this problem. Okay. If you know the formulas, and I would say if you don't know them, it's something we've covered in pre-algebra. If you don't know them, look them up. Right? What is the surface area of a prism? This would be a prism. Okay. Volume is area of the base times the height. So the area of the base, we actually just did 5x. And then the height is 10. Okay. Notice this is 5x times 10, not 5 times 10. So 5x times 10. So notice on this one now, we have, let's actually zoom in, make this nice and big for us. We have the variable on both sides of our equation. Okay, and I've got a lot of simplifying I need to do here, so we'll take a look at this in a minute. Let's simplify this a little bit, or let's kind of multiply out. 5 times 10 is 50, so this is 50x equals, and then all of this stuff. Well, this is just going to be 10 plus 2x times 10. So the distributive property would say I have 100 plus 20x, and then this other stuff is plus 10x. Okay, there's a lot to do, a lot of simplifying on this problem. Okay, we write the formula, we plug in the numbers, and we're setting them equal because that's what the situation said, right? The surface area and the volume were equal, and we've simplified. But notice what happens. Let me take one step further on this side because I can also combine these. Okay, so I've got 100 plus 30x equals 50x. Okay. So surface area equals volume, but notice there's a variable on both sides. And the idea is, what you want to make sure you do is it doesn't really matter which way the variable goes, but you want to move it away from the numbers. You want to put all the numbers on one side, all the variable terms on the other. So I'm going to move this guy by subtracting. Okay? Since there was a number on this side already that didn't have a variable, I'm going to leave that alone. 100 equals, and then put my variables together, and I can solve. Okay? And so the last step would just be divide by 20. And I'll get x equals 100 divided by 20 is 5. So in fact, if I went back to this problem, I know that they were saying x was 5, that this front shape actually was a square. Okay? And so I had a square, which would have been nice to know, would have made things a lot easier for me. Okay, but this is the big picture of what we're going to be doing. This is a pretty intense problem with a lot to go through. They're not all that way. Most of them will look something like this. Okay, so again, the big picture idea, to solve equations with variables on both sides, collect all the variable terms on one side and the constant terms, the ones without variables, on the other. So for this one here, again, it's relatively straightforward. I want my x's to be on the same side. I'm going to leave the 15 here, and I'm going to add 2x to both sides. That will cancel out here. And then we've got 15 equals, keeping track of my equal sign, equals negative 5x. And then I can divide by negative 5. And x will equal negative 3. Okay, to check my answer, okay, it says check your solution. I'm going to go back to the original problem. Sorry, 15 minus 2 times x equals negative 7 times x. And we're asking, is it equal? Or that was our question. So I'm going to take my answer right here, negative 3, and plug it in. Is 15, negative 2 times negative 3 is positive 6. 15 plus 6, that's 21. Is that equal to negative 3 times negative 7, which is a negative times a negative is positive, positive 21? And the answer is yes. Again, if at the end they're equal, I know this is the correct answer. As long as my math is here correct and I can double check it, I know I got this one right, and I'm excited about that. All right. So example number 2, they can look different, they can look crazier. Again, now all of a sudden I have some distributive property I have to deal with, but the same principles apply. I'm going to start, instead of distributing, I talked about this the other day, this is actually multiplication, so I could divide both sides by 3 first, and I'll get 5x plus 2, keep track of my equal sign here, equals 15x divided by 3 is 5x. Okay. And I'm going to have this like minus 5x and minus 5x. And I end up with this. Be really careful, because a lot of times students will put the answer 0, and the answer is not 0. You have 2 equals 0. 5x minus 5x is 0. So let's talk about this for a minute. As I look at this problem, I'm like, well, 2 doesn't equal 0. This is not true, right? Don't write this, but I want to make sure I'm really clear. This is not a true statement. And what that means is they're asking you to find a value, solve this. They're saying find a value for x that makes it so that this side equals this side. And right now we're like, well, my x has disappeared. I don't even know what to do. So here's what you do. Here's what you do. You back up a little bit. Let me back up way back here. So I want you to see it on this step. Notice on this step right here, we had 5x plus 2 equals 5x. So you have 5x plus something equal to the original number you started with. Like, there's no way, if you add 2 to something, if I have 10 and I add 2, I'm not going to get 10 again. But that's what this says. 5x plus something equals 5x. Well, you guys, I think common sense would tell you, those are never going to be equal. But, okay, see if we can put some of our math back here. We did some math and we got this. So when you see something like this, where this statement is not true, what you're going to do is put no solution. Okay? This is a unique case that will come up every once in a while when you're trying to solve. Your variables might disappear and you get a number equal to something, but that's not true. That means there's no solution. There's no number you can plug in for x that would ever make it work. Unlike the previous one, where we plugged in negative 3, and it did make the left side equal the right side. 21 equals 21. Over here, notice very similarly, if I do I'm going to do the distributive property this time, just to show you this one. And you get negative 8y minus 2 equals 8y minus 2. That's different than what happened here. This one, there was 5x plus 2 equals 5x, right? So the x is disappeared. But here, notice both sides are equal. They're exactly the same thing. If I tried to do more, I would add 2 to both sides, and my 2's would cancel out. And I would be like, okay, negative 8y, sorry, there's a negative there, equals negative 8y. And I'm like, well, that's still true. And if I divided by 8, divided by negative 8 here, I would get y equals y. And I'm like, that's true. Okay? So if you end up with this, where you have two things that are equal, and they don't have to always be variables, they could be numbers as well. If you get two things that are equal, like we have right there, then I would say go back. Okay, again, I want to make sure you saw it even way earlier. We could have recognized that right here. Hey, both these are the exact same thing. There was supposed to be a negative there. Then if you see this situation, the answer is all real numbers. Again, what they're asking us is, what value could you plug in for y that would make the left side equal to right side? Well, if they're the exact same thing on both sides, you could plug in any number you want to. I could plug in 1 and it's going to work. I could plug in 18 and it's going to work. I could plug in 2,955 and it would work. So you write all real numbers, okay? So these are the two crazy, weird situations that you might run into, okay? What's going to happen, I want to make sure it's clear, you're going to solve as normal. If you get to a step where all of a sudden it says something equals something, and it doesn't quite make sense, right? I think we would all recognize this, x equals 0. That doesn't make sense, okay? Or over here where we have something equals exactly the same thing. Again, it could be something big like this. We ended up with y equals y. It could have been negative 2 equals negative 2. If you have something equal to itself, then the answer is all real numbers. You want to keep an eye out for this, okay? So I have a couple here, a couple of U-tries for you, and some of them might be like the ones we just saw, some of them might not. I want you guys to try them out, okay? Come back, and you can check out the answers. But again, I'm going to emphasize this. I really want to make sure. I'm not there. I'm not over your shoulder watching you. Some of you might just be like, whatever, I don't care, and fast forward through the video, or wait till the video comes out. Make sure that you really try this, okay? The best thing for you guys right now is to really work through these on your own, and make sure you're catching your mistakes as quickly as All right, here are the answers for these ones. I do want to point out on this one that I did put all real numbers, and I want to make sure you guys see specifically this one. Please look through all of them, but on this one, you have 1 minus p equal to negative p plus 1. In math, if you remember, there's something called the commutative property, and the commutative property says that you are allowed to switch the order of addition. Now, this is addition, okay? And if I switch the order, it's 1 plus negative p, which I could rewrite that as 1 minus p. So 1 minus p is the same as negative p plus 1. So those are the same, and I left it that way because I wanted to talk about it and make sure you saw that. But these are the answers for all of them. Again, you can double check and ask if you got any of them wrong. I'll try to help you, okay? This one says the circles are identical, and it says what's the area? What is the area of each circle? Well, if these circles are the same, notice what that means is that the radii, the distance from here to here, is the same on both. So on this one, it's x plus 2, and we're going to say that's equal to the radius of this one. Now they gave us the diameter all the way across. The radius is exactly half of that. It's halfway across the circle is the radius. So I would set these two equal. And that will allow me, if I'm careful, to subtract x from both sides. And I'll get x equals 2. Now I want to be careful. This is what students are tempted to do. And they circle, oh, hey, I got it. Hey, x equals 2. There's my answer. But like, that's not what they want at all. They don't want what x is. They want what is the area of the circle. Well, that's x. Okay. So now the area of a circle, I want to make sure we're paying attention, is pi times the radius squared. And be careful, the radius is not 2. if I plug in 2 here, the radius is 2 plus 2, which is 4. So I'm going to plug that in. Okay, 4 squared is 16 times pi would be our answer for C. But be careful, especially on multiple choice. I feel like students sometimes get really excited about multiple choice, but the mean sneaky people like me who make your multiple choice tests will do this. Because I want to make sure that you guys are reading and following directions carefully. I'm not doing it to be mean, but to make sure and evaluate, are you really carefully paying attention to what you're being asked to do? All right? All right, last one, if I think. Okay, we're going to stop. This section we'll do, it's a little break, in 2 days. So we'll kind of take a look at some other stuff tomorrow together on Zoom and kind of give you extra time to practice. So we're going to take a look at this. So a boat travels X miles per hour upstream the Mississippi River. Okay. Upstream. And on the return trip, it travels 2 miles per hour faster. So it goes upstream X and downstream X plus 2. How far does the boat travel upstream? Okay, how far? Well, here's the deal. This is something that's not up here, but to figure out distance, that is rate times time, or speed times time. So speed times 3. Notice in the picture it tells us something. It says they travel 3 hours upstream. So 3 hours going upstream. That's the distance. That's D. And then we also have downstream. They used green. It took them 2.5 hours to come back. So 2.5 times the faster rate. And I'm using this formula, distance equals rate times time. They traveled the same distance up and down, so I know these values are equal. But it took longer going up because they had to go a little slower, and faster coming down because it was a little faster, right? They were going faster. And so this is the setup of this equation. And then they ask you to solve for, again, how far does it? Now, again, I want to be careful. They want us to figure out what D is. Well, to get D, I need to first figure out what R is. I already know the time. So I need to figure out X, and then I'm going to plug it back in. And be careful about that. We're going to come back to this at the end if we're thinking carefully. Okay? So all that means is I would do the distributive property here. Okay? And then I'm going to subtract 2.5x from both sides. You're going to get 0.5x equals 5. And then I'm going to divide by 0.5 on both sides. And x is going to equal 10. So that means x, the rate, that's what we're saying x is, the rate, how fast they were traveling was 10 miles an hour on the way up, 12 miles per hour on the way down. So, in this case, what was the total distance? Well, they traveled 10 miles per hour for 3 hours. That's going to give me a total distance of 30. Okay, 3 times 10, 30 miles. Okay. Hopefully that's helpful. I want to be careful. I don't need to rush through any of these, okay? One of the beautiful things about this being on video is you could pause, you could rewind, you could think about it a little bit, you could ask questions, and I want to encourage you to do that because you guys know I'm available for you to do that. All right? We'll pick up tomorrow. You're going to try your homework. There might even be some questions that you haven't seen before, and I'm going to give problems to you like that and see how you do. I want to see you struggle a little bit, not to be mean, but to see you push through some harder concepts on your own. And then we'll take a look at some of those tomorrow and walk through a little bit more. All right? Hopefully that's helpful. If we need an extra day to tack on to do some of the stuff, I'm all for it. I want to help you guys and make sure you understand as much of this as possible by the end.